Okay, so let's do a review first on 14A inside of 4.1. We needed to know the end behavior of this thing. Make sure you look at the exact wording of the questions that will be used on the exam. So this question wants to know the end behavior, so you look at the degree and the leading coefficient. Since it's even and positive, we go up, up. That means as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to infinity. Remember what this is saying is, as x goes right, y goes up. And this is saying as x goes left, y goes up. Just so we kind of understand what that's talking about. Other things we see on here, since this is even degree and negative, it goes down, down. So it would look like this. Since it's odd and positive, it goes down, up. So it looks like this. Since this one is odd and negative, it looks like this because it goes up, down. If we look at 20 and we have to graph this thing, first we find the zeros by factoring it. These would be our zeros. Then we use those zeros to partition or break up the number line into pieces. We put all of these intervals over here. We test a point inside each interval, and we plug it into each of our factors. Make sure that when you multiply all these together, it has to get this. Make sure you have any pieces up here have to go here. And so we find plus, minus, plus, minus. That means that f is positive on these intervals, and f is negative on these intervals. And then you draw the graph from the chart. Everything in yellow you must have on an answer to this question, but I would assume that I should still see everything just to be safe, but bare minimum I must see everything in here. 22 is similar, but you had to factor it first by first pulling out a greatest common factor and then breaking this into two binomials. So if three things multiply together to get 0, one of them had to be 0. Solving each, you get these three zeros. You use those to partition or break your number line up into 4 pieces because you made 3 cuts. Each of these intervals goes along here, and each of our factors goes along the top. So when you test a point in this interval, like -5, you get positive, negative, negative, which means our function is positive in this interval, and you fill out the rest of the chart. So we get that f of x is positive on these intervals, and f of x is negative on these intervals. And when you put all that together in a picture, it looks like this. Notice also that x touches at this even degree. It crosses at these two odd degree factors. So touches and crosses. Okay. Again, when we're looking at this, I would expect to see my zeros, where f of x is positive and negative, and the picture for an absolute bare minimum. But we probably need to show everything. 28, it is already factored for you. So finding the zeros is easy. We get this. You just set each factor equal to 0, but the only way that x squared can be 0 is if x is 0. The only way that x squared minus 1 can be 0 is if x minus 1 is 0. So we get these zeros. Those 4 zeros cut the interval into 5 subintervals, which are here. And notice all of these factors must be along the top. When we fill out the chart, we get positive, a bunch of negatives, and a positive. So that means that f of x is positive on these two intervals, and it's negative on these 3. You can use this information to draw the picture, and also notice you have some confirmatory evidence up here. Since this and this factor are squared, that means at 0 and 1, we would expect it to touch, and it does. Since these factors are really raised to the first, we would expect at -2 and 2 for it to cross, which it does. So that multiplicity tells us what's going on. Also, the in behavior conversation is down here. The absolute minimum thing we would need, as we said earlier, is you better tell me how you got the zeros. Tell me this part over here where it's positive and negative. And then also give me the graph of this sucker, yeah? Cool. Make sure that that's absolutely as big as it can be. Okay. So there's that, this I'm going to make big. This I'm going to make here. Okay. Similar. This is very similar to the other one, so I'm not going through it. Okay. Here they are saying find the quotient and the remainder. When this is divided by this, the key thing that we need to know there is you must have a placeholder if you are missing one of the powers. Here we were missing x to the 0 power, in other words, the constant. So you must put in placeholders if you're missing them in either what you're dividing by or what you're dividing into. The other thing, you must have these parentheses. If you don't, you will screw stuff up. Here they said use the remainder theorem to evaluate f of 2. Well, f of 2 is just the remainder you get when f of x is divided by x minus 2. That is what the remainder theorem says. That's really the key to the whole thing. So when you divide this by x minus 2, you get a remainder of 16, which means that f of 2 is 16. Okay. So that's using the remainder theorem. Here, this is using the factor theorem. So how do I show that x plus 4 is a factor? Well, since when you plugged in -4, you got 0, that means x plus 4 is a factor. That's what it means to use the factor theorem. Here they said these zeros must be in my polynomial. Can you make it? Well, if this is a 0, then this is a factor. If this is a 0, then this is a factor. And if this is a 0, then this is a factor. You multiply all those factors together and you get a polynomial that does what you want. Notice I multiplied it all the way out. Here, they want to see if you can do synthetic. They force you to do synthetic. The important thing here is we needed 2 placeholders. This is what people screw up. You must have placeholders. Remember, you always start off by, if you're dividing by x plus 2, what goes in here is -2 inside of synthetic division. Okay. Number 46, this one was super interesting. So if I've got this and I want to know when will this be a factor of this, well, if I divide this by this and get a remainder of 0, then this will be a factor of it. So these are just constant numbers. So I pull off all of my constants. Notice first I had to put this 0 placeholder. I pull off all my constants, and if I'm dividing by x minus 1, that means a 1 goes right here. And I just do synthetic division. Bring this down, multiply to get this. Add these, multiply to get this. Add these, multiply to get this. And add these. I found out that the remainder I get when you divide this by this is this chunk of stuff. But for this to be a factor of that, this remainder must be 0. So I set it equal to 0 and solve for k. I find out that if k is 3 or 1, then this will be a factor of that because the remainder will be 0. 4.3, I'm going to keep plugging until people come in. 4.3, it wants to know, find these zeros and their multiplicity. It's already factored for you. So this is a 0 with a multiplicity of 2. This is a 0 with a multiplicity of 1 because it's raised to the first. And this is a 0 with a multiplicity of 3 because the factor associated with the 0 is raised to the third. Same thing here, so I'm not going over it. 20. Now, what if they say find the factor, well, find the zeros in the multiplicity? If they don't give it to you factored, you must know how to factor. Always take out the GC, greatest common divisor first. Greatest common factor, sorry, GCF first. Then what's left, you have to be able to factor. Okay. So we get this squared, and then it looks like before. 3, 0 with a multiplicity of 3, and 5/4 with a multiplicity of 2. Same thing. Find all the zeros in their multiplicity. You must be able to factor something like this. So here I end up using the AC method to get this times this, But then this can be factored using the difference of two squares. So I've got my two zeros and their multiplicity, and this gives you plus or minus 5i. Each of those would have a multiplicity of 1. Notice I had 4 zeros, which I expect because I have a 4th degree polynomial. For 4, the thing here is, if negative 2 minus I is a 0, then because they come in conjugate pairs, negative 2 plus I must also be a 0. So if this is a 0, this is a factor. If this is a 0, x minus 2 is a factor. If this is a 0, is that 3 or 2? Oh, these should be 2s. Let me go back in here and fix this. So these should be 2s. So I'll upload that in a second. Cool? All right. So then if these are all your factors and you want to find a polynomial that goes through all these zeros, you simply multiply them together. And on these questions, very carefully read the directions. They say you can leave it in linear and irreducible quadratics. So when you multiply these out, just like in the homework, you should be able to get something like this. 14, it says, show that there are no rational roots. Well, first you would list all the possible rational roots and then try each one of these. When you try each one, you never get 0 when you plug in. That means none of them are roots. So there is no rational roots because they must have looked like this. 20, it says find all the zeros and they give you one to start, or at least I did. Here's how you do it when it's on the test. If negative 3 is a 0, then x plus 3 is a factor, which means I should be able to divide this by that and get a remainder of 0, which I do. I get this. So what's happened is I've taken this and pulled out the 0 of negative 3, and what's left behind is this piece. So it's got the other two zeros in it. So my original thing is equal to this times this. So if I factor it, I now can find all of the zeros. Boom, boom, boom. Again, similarly, when that's on the test, if I give you 1, 0, if negative 2 is a 0, then if you divide by, oh no, did I do negative 2 or plus 2? I should have said hint x equals 2 is a 0. So that should have been x equals 2. So hint x equals 2 is a 0. So if x equals 2 is a 0, then we're dividing by x minus 2, yes? And then when you do, you end up getting this left over, which makes sense that I get a remainder of 0 because this is a factor because you told me that that was a 0. So the other zeros must live in here. So if my thing is equal to x minus 2 times this, then I factor this to find my other two zeros, which are this, this, and this. So hopefully when that's on the test, you'll have a good experience. I'm going to stop there. Have a great day. I'll do the rest of it next time.